basically the less sensitive you are to large-scale regional features. And the lower signal to noise is simply due to the fact that you're taking a derivative, a gradient, relative to the original magnetic survey. Okay, I'm going to go through, we're not going to go through, I'm going to let you read about a bunch of this. This is something that Nella is going to go talk about on Friday and Monday. There is one thing that happens in magnetic surveys that doesn't happen in gravity surveys. You've probably read that in gravity surveys we have a time-dependent effect associated with tides. Those are usually very predictable. They're pretty small, but if we're looking for high resolution in the gravity survey, sometimes we have to correct for tidal variations. And that's a tide-independent thing, and we use a calibration measurement to do that. Magnetics is a little bit different because there can be very wild magnetic fluctuations that are associated with sunspots or basically magnetic storms. And the magnetic field intensity can jump around like crazy during the day. And obviously if I'm collecting data at this time versus this time, I'm going to have a real hard time comparing those two magnetic measurements. So on a day where the magnetic storms are high, we usually don't like to collect data. It's just almost impossible to make those corrections. Whereas if you have a quiet day and you have measurements along here at some kind of magnetic base station, you can compare data. You essentially understand what the magnetic measurement is in between every one of those squares. And you do this by continuously recording a base station. Does everybody understand how a base station works? It's really very, very simple. Imagine this. Let's say that I have a bunch of magnetic or gravity surveys. So these are my survey points, and this one is taken at 12, 10. This one's taken at 12, 12. Maybe this one's taken at 12, 30. This one's taken at 12, 45. This one's taken at 1, 1. And all these things have a time associated with these measurements. Okay? Now let's say that I have another station over here. And every time I make one of these measurements, I also make a measurement at a fixed location. So I make a measurement here at 12:10. I make a measurement here at 12:12, 12:30, etc. I'm making a measurement at every place, and there's some kind of anomaly in here that's generating a magnetic field. Everybody understand what I'm doing here? I've got a base station, and then I've got my survey data. So the base station, because of this effect right here, might look something like this. Okay, where these are my points. So this part we're going to call, this is a number, right? This is a value that I measure from my base station, and it changes with time. Okay? What do I need to do to compensate this time change in my real survey? Well, this effect is simply probably due to magnetic storms or things that are going on in the atmosphere, right? I don't want this impacting my survey. Okay? If I made a measurement gonna tell you how the magnetic field changes with time. So all I have to do is subtract the base station readings from each of the individual readings at that time, and I've corrected for the time-dependent changes in the magnetic field. And I can do the same thing with gravity, right? If I have two gravimeters, I can have a gravity base station, make these measurements, and do the same correction.
Wouldn't these measurements
No, this base station is where, um, yes and no. That's a good question. So the question was, if I'm over here and this is over here, do I have a different magnetic field at both? The answer is yes. We assume that the time-dependent changes are due to something over a large area. So as long as the base station is relatively close to where you're doing the measurement, we're basically making the assumption that any changes that we see from here to here don't matter.
Are base stations usually like a temporary setup, like a magnetic schema where you're working, or is it are there permanent base stations?
No. In regional areas, the USGS has some base stations, but usually something you can come out of, particularly with the local surveys. So you either have to come out with two sensors, or what could you also do if you only had one magnetometer? Well, we could basically make this measurement, this measurement, this measurement, then I could run over and make another base station measurement, run back and do this. So I wouldn't have a magnetic value at every point, but maybe I'd have it at a few values in there and I can interpolate. So that's a poor boy's way of doing gravity or magnetic correction. You just occupy that base station. You go back and reoccupy the base station at different points in the survey. Sometimes people will just do it at the beginning and the end of the survey, and then just assume that whatever changes occur in between there were linear.
So when you're subtracting, you're just saying what the difference of the base station is, then wouldn't the base station also fluctuate?
The base station will fluctuate, and we assume that the base station is fluctuating exactly the same as the time-dependent fluctuations are the same as the measurement. So remember, the measurement position is a function of space and time. But we're assuming that the base station doesn't have a function of space, but the time dependence is exactly the same as the measurement. Okay, so Nella will handle, she'll basically be going in more detail over the homeworks for the next two classes, just to get you guys up to speed. But again, I'm not as worried about your homework performance probably as you are.